This is Dr. Holt again. I want to go over higher order homogeneous differential equations, constant coefficient. This is part 2. We're going to get into the polar form. Again, I like to stress just the facts, not the fluff, and that I like to provide you guys with enough tools necessary to solve the problems related to your homework or getting ready for an exam or quiz, and not focus so much on the theory behind this. A lot of textbooks are written with a lot of theory, and sometimes they're complicated to read. However, hopefully in this video, this is going to give you the tools and the skills necessary to solve some of these differential equations, especially in polar form. If you have an equation in polar form, or where you're going to have to write an equation in polar form, is when you have a higher order differential equation. Let's say we have y going to 4 prime minus 6y is equal to 0. If you have one like that, the only way to solve that problem is to put it in polar form. Now this one here represents this equation here, which is, when we see that, we know immediately we got to go to polar form. To do this, we're going to establish the r value. R is going to equal to the absolute value of a. A is going to represent the -6. And then we're going to write this into lambda k is equal to r times 1 over n, not times, r raised to the 1 over n power times e raised to the power of I, and then in parentheses we're going to have alpha plus 2 pi times k divided by or multiplied by 1 over n, or you can just say divided by n. Now your k value, you're going to let your k run from 0, 1, 2, dot, dot, dot to n minus 1. So n is going to represent whatever derivative you're going to. For example, with this one being 4, we would stop at 3. Our k values would be 0, 1, 2, and 3. Alright, now with these you're going to have two conditions. Since this one here we have yn minus a to the y is equal to 0, again this represents this form right here. In this case we would say that a is larger than 0, so we're going to let alpha here be 0. Now that always holds. If this is a case, alpha here will always equal to 0. The second case, if you're adding, you have y going to some fourth derivative, fifth derivative, and you're adding here plus ay, then a here would be less than 0 because you're adding. So you're going to let alpha be equal to pi. Right, those are two conditions. It's critical that you follow this, because if you fail here, you're going to get the wrong answer. All right, let's look at a problem. Let's slide this down. Let's look at this one here. We have y going fourth prime, or y to the fourth derivative, minus y is equal to 0. We're going to solve for that. We're going to rewrite that in terms of lambda. Lambda to the fourth minus 1 is equal to 0. In this case, we know two things. We know that n is going to equal to 4, and we know that r is going to equal to 1. Okay? We also know that a, in this case, is going to be larger than 0 because we're subtracting, we have the 1. So we know that alpha has got to be equal to 0. Alright, again, I recommend that you write this down just like this and then just put it into the lambda k form. So in this case, lambda k is going to equal to our r value, which we said in this problem is going to be equal to 1. Let me put that back over here too. I need to write that down. It's 1. So I put 1 down. I go ahead and multiply that by e. We raise that to the power of I. In parentheses, we're going to have 0 plus 2 pi times k times 1 over 4. Okay, we'll go ahead and simplify that. Lambda k is going to equal to 1 times e to the I. And now since we have 0, we'll go ahead and simplify that. That's going to give me pi over 2k. Okay, and we also know that k is going to stop at 4, so that means k is going to equal to 0, a 1, a 2, and a 3. Alright, so now what I recommend is go ahead and solve it for each condition. For k is equal to 0, our value here is going to be equal to, our lambda 0 is going to equal to 1 ei of 0. So we're going to have to write that in polar form. So to do that, that's going to give me 1 times the cosine of 0, which is, we're going to write that down, cosine of 0, plus 1 times the sine of 0, and I need to put the I in here also. When we simplify that, that's only going to give us 1. So we can say that lambda 0 is equal to 1. Alright, we'll do our next condition. K is equal to 1. In this case, lambda 1 is going to equal to 1 times e to the I of pi over 2. Okay, we'll go ahead and put that in polar form. That's going to equal to 1 times the cosine of pi over 2 plus 1 I of the sine of pi over 2. Alright, when we solve that, that's just going to give me, this is going to go to 0 here. Cosine of pi over 2 is 0. So we're going to be left with lambda 1 is going to equal to just 1 I. Alright, so let's go ahead and circle that. We got this one, and we have this one here. Okay, let's go ahead and do the next condition. We're going to let k is going to equal to 2. So lambda 2 is going to equal to 1 times e to the I, and that's going to take us directly to pi. Move this up a little bit. So again, we put that back into polar form. So 1 is going to equal to the cosine of, sorry, not 1a, sorry about that. That means that 1 times the cosine of pi plus 1 I times the sine of pi is equal to lambda 2. So in this case, lambda 2 is going to equal to negative 1. Alright, we almost got this nailed. We got one more to go. We have k is equal to 3. Move this up. So when k is equal to 3, lambda 3 is going to equal to 1 e to the I of 3, what is that going to give me? 3 pi over 2. We go ahead and solve for that in terms of polar. Lambda 3 is going to equal to 1 times the cosine of 3 pi over 2 plus 1 I times the sine 3 pi over 2. That's going to give us to lambda 3 is going to equal minus I. Alright, so we got everything we need here. We got all our lambdas. So now, just to write that as our solution, we'll have y is equal to c1. We'll go ahead and use our 1 first. That'll be e to the t power. Sorry, let me move that up. Sorry about that. Plus c2. We'll go ahead and do the negative 1 of e to the negative t. Alright, and then we'll do, we got plus or minus I. We got a plus I and a negative I, so it takes us right to our cosine and our sine, so to get a plus c3 of the cosine of t plus c4 times the sine of t. And that's the solution to that differential equation, and using with it what's called the polar form. Alright, that's not too bad, I hope. Alright, let's look at one more. Slide this down. Let's look at this problem here. We have y triple prime plus 8y is equal to 0. We'll go ahead and solve that. In this case, we'll go ahead and do similar to what we did on the last problem. In this case, we have n is going to equal to 3. We know our a value is equal to 8. Our r value is going to equal to the 8 here. We know in this case, since a, I should have said earlier, a is really equal to negative 8. A is going to be less than 0. So what that tells us immediately is that alpha is going to equal to pi. Again, I recommend you do this on every problem like this, and then they're really quite easy. We'll write this in terms of lambda cubed plus 8 is equal to 0. We'll go immediately back to our lambda k. Lambda k is going to equal to 8. Again, we're going to take, since it's 3, we take this to the 1/3. Okay, we're going to multiply that by e to the I. We're going to raise that to, now this is going to be pi plus 2 pi times k times 1 over 3. Alright, so now let's go ahead and see if we can simplify this. So we can say that lambda k is going to equal to 2 ei of pi plus 2 pi k. And what you can do here, if you want, you can just make these each over 3. Alright, so now let's do our three, how many conditions we have? We got 0, 1, 2, and 3. We have 4 conditions. So we'll do k is equal, I'm sorry, we have 3 conditions. We got the third derivative here. So we're going to do k is equal to 0 first. So when k is equal to 0, we'll go ahead and put our values in. That's going to give me 2e to the I of pi over 3. We'll write that down, and that's going to give me in polar form 2 times the cosine of pi over 3 plus 2i times the sine of pi over 3. Okay, when we solve for that, that's going to give me 1 plus I times the square root of 3. Alright, so that's what lambda 0 is going to equal to. Alright, we'll go back to k is equal to 1. When k is equal to 1, then lambda 1 is going to equal to 2 times e to the I, and that's going to give me 3 pi over 3. Or just pi, right? Alright, so to write that in terms of our polar form, we'll have y1 is equal to 2 times the cosine of pi plus 2i times the sine of pi. Scroll that up a little bit, or move that up. So when we solve for that, that's going to give us a value of -2. So lambda 1 is going to equal to -2. I'll go ahead and circle this one and circle this one. Alright, we got one more condition. K is equal to 2. So when k is equal to 2, lambda 2 is going to equal to 2 of e to the I. And when we put in the value of k, that's going to give us a value of 5 pi over 3. Okay, we'll write that in terms of polar. Y, or lambda 2, is going to equal to 2 times the cosine of 5 pi over 3 plus 2i times the sine 5 pi over 3. Okay, when we solve for that, that's going to give us 1 plus, I'll make it 1, yeah, I'll go ahead and do this. 1 plus I times the square root of 3, and that's going to be a negative. Now, or we could just do this, right? 1 minus I times the square root of 3. So that's what lambda 2 is going to equal to. Alright, so now we have enough to write our solution down. So we've gone through all 3 conditions. So now our solution, move this up, it's just going to be y is equal to c1. And we come up here, we'll use the -2 first, times e to the -2t. And now since we have the i's, we know we have to go, or the complex, we know we're going to have to go to the cosine. So that's going to give me plus c2. Now, since we have the 1 here, we have to do e to the t. And that's going to be the cosine of the square root of 3t. And then plus, hopefully I can get this right in here, c3 e to the t of the sine of the square root of 3t. Alright, so that's the solution to that differential equation. Again, that's used in polar form. Not too bad. Again, I would recommend, let me move this up. I would recommend that you follow these steps here. Go ahead and identify your n value, your r value, determine whether an a is going to be positive or negative, and then determine whether alpha is going to be 0 or pi. Then go ahead and write it in terms of lambda k is equal to r to 1 over the n power times e times I of alpha plus 2 pi k times 1 over the n. And at that point, really, it's not too bad. And then when you're done going through all 3 conditions or 5 conditions or whatever you have, just go ahead and just put the values in, and that will become your solution. All right, this is Dr. Holt. I wish you best of luck with these differential equations. Again, sometimes it can be complex, but if you follow a methodology or a strategy, you shouldn't have any trouble.